Hello everyone, my name is Ali and today we'll be talking about genetic bottleneck. If you enjoyed this video or like this video and would like to support this channel, feel free to subscribe and like down below. Now, genetic bottleneck is a form of genetic drift that occurs when a population is drastically reduced in size. Now, the resulting individuals are the only ones that actually contribute to the next generation. Therefore, only the frequencies or the variations in these genes, the genes of these individuals, are going to be contributing to the next generation. Therefore, this is going to be incredibly annihilating the genetic variation that was present before. Now, genetic bottleneck is an evolutionary event where a significant percentage of a population is either killed or prevented simply from reproduction. This results, like we mentioned before, in a decrease in the genetic variation, and it reduces the population's ability to adapt to selective pressure. Now, to just emphasize on this statement, let's understand what we mean. If we have genetic variation within a population, for some reason, I've used this analogy multiple times, but it's very easy to get the point across. If a certain organism is staying in an area like a desert and a harsh winter was upon them, if there was enough genetic variation within a population of this organism, what is going to be happening is that, well, most of these organisms or individuals are going to be dying, whereas a few are going to be surviving, and this is due to their genetic variation. However, if the vast majority of these individuals in a population actually had the same genes or very small differences, what is happening is that these harsh conditions are going to be annihilating everyone in this population, and no one is going to be surviving for the next generation. Now, genetic bottleneck happens over a short period of time due to the different environmental conditions. Now, following genetic bottleneck, there are two possible outcomes. We either have the recovery of the population, but the population will still have low genetic variation because simply we've got a few individuals that have formed a large population. However, these people did not introduce, no new genes were introduced to them by migration. That, by the way, we are going to be talking about in future videos. However, no new genes were introduced, and the mutation rate, as mentioned before in previous videos, are very low. So they will have small genetic variation, or simply they are going to go extinct if it was triggered. Now, looking at this image, we've got the population size in Y and time in X. We've got a bottleneck event at a certain time frame. Now, what is going to be happening here, what we see is the population size is going to be dwindling in number, and it is going to be leading to there's going to be a point where it's going to be either going up again, which means recovery, and recall that this recovery is still going to be still entailing the fact that these people in this population will have small genetic variation, or extinction of this population.